pens to be down. Thank you. Perfect. So, on the board, I've asked you to add 2 sets of fractions, and then I asked some of you to move on to subtracting the fractions, okay? Now, before we start any of the modelling there, I want to ask you these first key questions here. So, first of all, what is the problem with these calculations here? Whenever I see fractions, and whenever I'm asked to do a calculation with fractions, what am I asking myself before I start that calculation? Whether it's multiplication, whether it's addition, whether it's subtraction, whether it's division. There's a question that I always have in my head. Maisie, what do you think I'm asking myself at this point?
Are the denominators the same?
Good girl. Are the denominators the same? Why do the denominators need to be the same? Any ideas? Who can tell me? What can I not do unless my denominators are the same? Archie?
It would make it easier to compare, because you can just see the 2 and the 1 of the...
Perfect. So at the moment, Archie, what you're telling me is if I look at this first calculation, these fractions are from different families, aren't they? Because these are thirds and these are quarters. So at the moment, we can't make any real comparison if we were being asked to compare, and we can't add because they're not from the same family. Okay, so what do you think I need to do? What strategy could I use to make these fractions, or to turn these fractions into the same family? Who could help me there? Maisie? I need to find a common denominator. Good girl. I'm going to jot that term down, because that's a really important mathematical term. What does a common denominator mean? What is a common denominator? I wonder if someone different can help me with that one. Oscar?
So it's where there's a number that's in both times tables.
There's a number that's in both times tables. So if I'm going to have a strategy that I could use now, what would you advise me to do here? And I've seen lots of these strategies on your board, so I'm sure everybody should be able to contribute something here. Oliver, what would you do?
You could list down your 3 times table and your 4 times table.
Perfect. So down here, I'm going to list my 3 times table and my 4 times table. So can you all count with me now? We're going to start with 3s, and how far am I going to go? How will I know how far to go? Who can answer that question for me? Emmy?
When you get to the number that you need to get to, so you do about 2 or 3 of one of your times tables,
Yeah.
and then 2 of your own.
Yeah, there's no point listing 100, is there? 100 different options for the times tables of 3, because actually we might not need that many. So we'll do a handful, and then we'll do the same for the 4 times table as well. So count with me. First one, 3, a bit louder.
6, 9, 12, 15, 18, 21, 24.
I'm going to stop, okay? Going to do the same now for the 4 times table. So count with me. Let's go.
4, 8, 12, 16, 20, 24.
Oh, I'm stopping. Why am I stopping? How do I know to stop at that point? I could have probably stopped before that point. Let's have Sophie.
Because the 12's in both times tables, so you found your common denominator, so you don't need to go any further.
Perfect. So I've got 12 here in the 3 times table list, and I've also got 12 here. Are there any other numbers in those lists that appear that are common multiples, perhaps? Any ideas? Maisie?
24.
There's 24, isn't there, if I wasn't sure? I've got another option there. But I'm going to go with 12. So what I'm going to do now, I'm going to rewrite those original fractions out just because I've got no space. So I've got 2/3 plus 1/4, and I'm now going to convert them to 12s, a little bit like you've just told me. So I've now got a new denominator of 12 for both. Now, there's another question at this point that I have to ask myself. So, I somehow have gone from 3 to 12, a denominator of 3 to 12. What did I multiply multiply my 3 by to get to 12? I wonder if Holly could answer this question. Holly, what do I times 3 by to get 12?
Get 12 is a very hard one, but you might need to be oral Stein for that.
What do we multiply 3 by to get to 12?
4.
Good girl. So 3 times 4 gives me 12. Now we know that with fractions, whatever I do to the denominator, I must do to my numerator. Okay? So if I times 3 by 4 to get 12, what have I got to multiply my 2 by? We've got to be fair with the denominator and the numerator. Everyone's hand in this room should be up now. We should know these rules. Go on, Kate.
Times it by 4.
I've got to times it by 4 as well. So, Kate, what's 2 times 4?
8.
Good girl. So, I've now got a new fraction of 8/12. Same principle here. What did I times my 4 by to get 12? Really important, you check your denominator and how it transforms to the new denominator. Oh, let's choose, go on Maisie.
3.
Times it by 3, so 4 times 3 gives me 12. 1 times 3 gives me 3. Okay, can I now add these fractions? Yeah, because they're both from the same fraction family. Do I have to add my denominators?
No.
No? So I'm just adding the numerators. Archie, what would my answer be? 8 add 3.
11, 12.
So 11 over 12. Thumbs up if at this point you understand the need to convert those fractions. Wonderful. I'm going to give you a couple of minutes now just to check the subtraction one, and then we're going to follow the same strategy, but you've got to convert those denominators. So have another look at your board, check you've done the subtraction one, and then we will model. Off you go.